This is a short introduction of multi-communication system in microgrid. Designing system consists from model of microgrid implemented in MATLAB Simulink, where SM Boost subsystem responsible for calculation of electrical system parameters and SC SMD1 is responsible for measurements, observing, and for input signals. SM Boost subsystem can be divided by two parts: energy system and communication system. Energy system can be represented like on the picture at the top left corner. Communication part presented by two types, UDP and GOOS. GOOS, generic object-oriented signal events related to 68050 standard of communication. Both UDP and GOOS capabilities supported by O-polarity simulator. SC SMD1 subsystem design is pretty simple. It consists only measurement observing block, switch for connecting and disconnecting utility from the common grid, and reference signal for modeling of photovoltaic power production. To run simulation, we need to load it and press the start button in O-polarity environment. Model can be running in two scenarios. In the first one, the load consumes energy produced by utility and PV. Battery does nothing in that case. Another scenario will be if utility source will be disconnected. The battery should compensate difference between consumption and production levels in that case. After simulation is running, we need to run the multi-protocol application. This application supports 3 communication protocol, OCPP, OpenIDR, and 68050. It means that this application can not only send and receive messages by using one of the protocols, but also convert some data from one protocol to another. After application is opening, communication through 68050 can be observed. For additional measurement obtaining, some OCPP and OpenIDR devices should be running. After device initialization, data on the main application window will be updated and colored with a green, which says that some device is detected, and now application can send and receive message through all of 3 channels. By clicking on the grid tab, you can easily observe some power measurements related to the modeling system. Grid data, presented here, obtained through the 68050 protocol. PV data received through the OpenIDR. Battery data obtained through the OCPP. Load measurements calculated as a sum of 3 measurements, battery, PV, and utility, and not transmitted or received to or from outside. For battery block, simple algorithm reducing the maximum of produced power is applied. According to that algorithm, battery will be trying to adjust the energy production level to not more than 11 kilowatts. If this reference will be reached, signal through OCPP protocol will be sent back to electrical model as a feedback. This was a short introduction of multi-communication energy system.